Hi friends, today we are going to study second problem of velocity and acceleration analysis. It is given like this: an engine mechanism as shown in figure has the crank CB 100 mm and the connecting rod AB 300 mm with center of gravity G 100 mm from B. In the position shown, the crankshaft has a speed of 75 radians per second and an angular acceleration of 1200 radian per second square. Find velocity of G and angular velocity of AB and acceleration of G and angular acceleration of AB. So let us see how to draw velocity and acceleration diagram. So what is given? Omega BC is given 75 radians per second. Alpha BC is given 1200 radians per second square. Length of CB 100 mm. Length of AB 300 mm. So this is what is given. Now we have to first find the velocity of B with respect to C, and it is given by V equals to omega R. What is R? R is length of the crank CB. So by substituting we get magnitude 7.5 meter per second. The next step is we have to draw the velocity diagram, and for that configuration diagram is very important. So let us draw the configuration diagram. Take scale, 1 centimeter equals to something millimeters, and you will get the configuration diagram. To draw velocity diagram, I told you that the velocity vector can be drawn on a paper if we know two things. One is magnitude, that is velocity of B with respect to C. B with respect to C, if you know the magnitude, and it is given 7.5, and if you know the direction of rotation of a crank, that will decide the direction of velocity vector. So in this case, this crank BC rotates clockwise. Since it is rotating clockwise, the direction of velocity is in the direction of rotation. It means from B2 towards right. So this line indicates direction of velocity vector. So let us draw. You have to always think fixed point for drawing velocity diagram. So here point C is fixed, so it will start from fixed point C. So this is point C. From point C, draw a line perpendicular to BC. So always remember, this is BC. You have to draw a line perpendicular to BC from fixed point C. So this is C. Draw a line perpendicular to BC. So the length of this line will be equals to the magnitude 7.5. By taking some suitable scale, you can get the length of this vector. So this is point B. Now always try to say velocity of A with respect to B is perpendicular to AB. When you repeat this sentence, it is very easy to draw the velocity diagram. So what I told just now, velocity of A with respect to B is perpendicular to AB. Now you have to just see where is point B. So this is point B. From this point B, draw line perpendicular to AB. So let us draw. So this is the line which is perpendicular to AB, but we don't know its magnitude, so let it be. So just simply draw a line and think how this slider will slide. So it will slide horizontally. It means from fixed point C, draw a line parallel to direction of slider. So this is slider which is sliding horizontally. So I have drawn line parallel to the direction of slider. So intersecting point will give you point A. So after getting the point A, I want to locate point G. Again you know the distance ratio formula by taking BG by BA equals to small bg by small ba. You can get the distance of B to A, and by knowing the distance you mark point B and you will get this velocity diagram. Label all the points and measure the velocities. So this is step number 1. We have drawn velocity diagram. To draw acceleration diagram, you have to prepare a table, and everyone know what the table is. Length, velocity of each link. You have to take it from velocity diagram. Then acceleration has two components, centripetal and tangential. Centripetal component is v square by r, and you can get the centripetal component of each link whose velocity is known. That is very important. So you can get this column filled. The last column is tangential component alpha into r. Alpha is angular acceleration. If it is given, you will get the angular tangential component of the acceleration, and in this case alpha bc is given, so alpha into r, length of that link, will give you the tangential component of acceleration. In second case, AB, only FC is known, EFT is not known, so magnitude not known and direction is perpendicular to AB. You know this, so let us draw. So draw configuration diagram. You already drawn. To draw acceleration diagram, you have to consider, you have to say like this: acceleration of B with respect to C will have two components of acceleration. One is centripetal. Centripetal is parallel to the link, and tangential perpendicular to the link. And in this problem, since angular acceleration is given, so we know both the, say, FC and EFT in this case. So point C is fixed, so let us mark point C. While marking point C, you have to always see that where is point B. So this is B and this is C. So the centripetal component will move like this, from B towards C. Though it is moving from B to C, but you have to take point C here, somewhere here, and then you draw a line parallel to the link BC, and the tangential component is perpendicular to this link CB. So let us draw. So this is point C, this is B1. Remember, this is B1 because it has got tangential component also. So this is point C, this is point B1, which this line indicates centripetal component of acceleration. Now draw tangential component. You know magnitude, you know direction. So this is tangential component of acceleration. When you join these 2 points, you will get acceleration of B with respect to C. Now next one is acceleration of A with respect to B. We'll have two components, centripetal, tangential. Centripetal parallel to AB, tangential perpendicular to AB. So let us draw centripetal component of acceleration from this point B. Always remember, this is point C, this is B1 and this is B. From B, draw line parallel to AB, indicating centripetal component of acceleration. Draw perpendicular to AB, which will show you tangential component of acceleration of A with respect to B. Now since the slider is sliding horizontally, so draw line parallel to this AB from point C. So these two lines will intersect here, and this is nothing but point A. Now join this A and B to complete the acceleration diagram. Now you want to locate point G, and everyone know how to locate G. So you will get that point G and then join G to C. This way, label all the points and you will get acceleration diagram. I hope you can get it. Thank you.